Go. Here's Venn Diagrams, page 5 of section 2.2's notes. The rectangle represents the universal set. So everything that lives in this rectangle is the universal set. It's what we're studying. So if we want to talk about WCHS students, that goes inside the rectangle. The portion bounded by the circle represents a subgroup, a subcategory, a smaller group. And that smaller group could be, in our case, seniors. So A equals seniors. If there's about 1,400 students here at Washington, about 400 are seniors. Okay, so 400 people will live in the circle, and 1,000 people will live in the rectangle, not in the circle, and that's called the complement. The complement of seniors is A prime. A prime is the complement. And we say it out loud, not in group A, or if you're British, not A. The complement of A contains every element in the universal set that's not in A. Does that make sense? So let's try a couple sample problems here. If they tell you the universal set is the set of integers 1 through 6 inclusive, and set A is these and set B are these, what is in not A? In other words, that lives in the universal set, but are not in A. Anyone? Somebody? What elements live in the universal set, but don't live in A? 5 and 6. So 5 and 6 are in the subgroup or subset, not A. How about not B? If B contains the even integers 2 through 6 inclusive, all the values in not B are all the values that live in the universal set that aren't 2s, 4s, or 6s. So, what would that be? Shout it out. Odds. So does anybody have any questions with that? Pretty self-explanatory. So far, so good. The subset of a set. Every element of A is an element of B. That's the definition of subset. Set A is a subset of B if every element of A is an element of B. Let's try that. The symbol for subset is like a U with a little underline. That is a subset of, almost looks like the letter C, doesn't it? Is a subset little letter C with the underline, slashed is not a subset. That makes sense. So, 1, 2, 3, 4 is every element from A also an element from B. 1, 2, 3, 4, 5. Yes. So the symbol we put in there is a subset. How about 2, 4, 6, 8 and 2, 4, 6, 8? Is every element from A also an element of B? If so, It's a subset. 0, 1, 2, 1, 2, 3, 4, 5. Is every element here also an element here? It is not a subset. And that's how it works. So far, so good? Look at this number up here, 2b, and what can you conclude about 2b? It's fancy. It's fancier than some of the other problems. Can anybody say something profound about 2b? They're the same. Okay, so yesterday we talked about the difference between equal, every element is the same, and then equivalent, the cardinality of each of the sets is the same. These are equal. So if two sets are equal, then they're subsets of each other. In other words, if A equals B, then not only is A subset of B, B is a subset of A. They're the same. So, moral of the story, every set is a subset of itself. Every set is a subset of itself. Let's take a break and talk about Google Classroom. I've done this before. I've made myself disappear. How about clicking that? Stop.